Hey guys, good morning and welcome back again to your Unacademy NEET English channel. I hope all of you are doing amazing, all of you are doing great. So quickly give me some fire emojis in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Quickly let me know in the chats. Quickly let me know in the chats. Everyone. Good morning guys, good morning, good morning, good morning. Good morning and welcome back. Good morning and welcome back. I would want you guys to call up everyone, okay? Call up everyone. Let's kill this session as well. My dear students, whatever questions, whatever types of questions can be asked from class 11th in organic chemistry, we shall be doing all those type of the questions, right? And let me tell you, since this is inorganic, so we do not have to solve questions. So to solve these questions, it will definitely take lesser time. So what I want you guys to know right now is the session duration is just going to be 4 to 5 hours. In 4 to 5 hours, almost like 400-500 different types of questions will be covered from the class 11th inorganic part, right? I know a lot of students are asking about the yesterday's PDF, but let me tell you, due to electricity shutdown, the screen got blank and I could not save the handwritten PDF. Okay, but I'll share the other PDF with you, but that won't be handwritten one. Okay? Okay? Right? It was the technical issue yesterday, so I could not save that handwritten PDF. I hope you get it. Yeah? I'll share the other PDF with you, but that won't be handwritten. Okay? And one topic which was left in the yesterday's session in the periodic classification, we'll be doing that particular topic in the form of questions directly, right? No need to waste any sort of time. Perfect. So which chapter do you want me to start with? Should we start with the chemical bonding questions or periodic classification questions? Quickly. We have got almost 700 slides over here today. Which chapter should we start with? Let me know in the chats quickly. We'll start with the bonding marathon. We'll start with chemical bonding, okay? Yes, all these are PYQs, NCRT, exercise, NCRT, in text, right? All the types of questions I've come up with. Okay? And you guys have to be very active in the chats today because you are the ones who are going to write the answers in the chats. Perfect? And I'm pretty much sure if you have watched the yesterday's marathon, you will be able to solve each and every question on your own. I'm pretty much sure about that. Yeah? So are you all ready? Are you all ready, people? A P block will be doing in class 12th inorganic marathon. Okay? So are you all ready? Quickly in the chats. Perfect, guys. All right. So I hope you all are ready with your pen and paper. Okay? And the first few, like 4 to 5 questions will be very easy, which I'll be solving right now. I mean, they'll be very easy. You do not have to use the pen and paper for them, right? Directly by looking at the questions, you'll be able to answer all of those. Quickly, let me know the answer of this particular question. Quickly. The attractive force which holds the atoms together in a molecule, what do we call that attractive force? The attractive force which holds various constituents, atoms, ions, etc. together in different chemical species, what do you call that as? You call that as chemical bond. Done and dusted. Look at the second one. Cation and anion. Cation and anion combines in the crystal to form which of the following compound? Quickly, you should be in a position to answer all of these. I'm pretty much sure. In ionic bond, what happens? During the ionic bond formation, we saw yesterday, metal loses electron, gets converted to cation. Non-metal gains electron, gets converted into anion. Then there will be force of attraction between that cation and anion. Right? You know it. So it is the ionic one. Perfect. Look at the third question. Look at the third question, people. Kill it. When a metal atom combines with non-metal atom, the non-metal atom, does it lose or gain electron? Non-metal atom gains electron. And if non-metal atom gains electron, its effective nuclear charge will decrease and its size will increase. Yes. When the non-metal atom gains electron, its effective nuclear charge will decrease and its size will increase. So option D. No need to think about anything. Right? Moving on. Which of the following does not represent the correct Lewis symbols? Which of the following does not correctly represent the correct Lewis symbols? Over here, carbon, and over here, they have mentioned 4 electrons. Over here, oxygen, they have mentioned 5 electrons. Neon, they have mentioned 6 electrons. And beryllium, they have mentioned 2 electrons. When you show the Lewis symbol, you need to write the valence electrons, right? You need to show the valence electrons. Perfect. So what do you think is the answer? Quickly. Quickly, people. Carbon has got 4 valence electrons and all the 4 valence electrons are shown over here. Yes. Oxygen has got 6 valence electrons, but only 5 have been shown. Only 5 have been shown. Only 5 have been shown. Neon. Neon has got 8 valence electrons, only 6 have been shown. Right? Rest everything is fine, I believe. Perfect. Second and third is the answer of this particular question. You all are absolutely right. I want the answers like this quickly. According to Fajans' rule, covalent bond is favored by. According to Fajans' rule, covalent bond is favored by. Covalent bond is favored by covalent character in an ionic bond that is decided by the polarizing power of cation. More the polarizing power of cation, more the covalent character. Polarizing power of cation is directly proportional to charge, inversely proportional to size. Right? Quickly. Similarly, covalent character is decided by the polarizability of anion as well. And you know polarizability is directly proportional to the size of anion. So quickly, I want everyone to answer this question. According to Fajans' rules, covalent bond is favored by smaller cation and larger anion. Smaller cation and larger anion. Smaller cation and larger anion. This question, the sequence of polarizability of these anions. You know, when I talk about polarizability, that is directly proportional to the size of anion. Right? That's directly proportional to the size of anion. Now, you know, among all these anions, I negative has got maximum size, so it will show maximum polarizability. Maximum polarizability means it will show maximum covalent character, etc., etc. Right? So I negative, Br negative, Cl negative, F negative. This is the polarizability order, which I believe everyone has written correctly in the chats. Wonderful. Moving on. Among these species, the covalent bond character follows the order. Covalent character order you have to tell in all these. My dear students, if you look carefully, this is Li positive, this is Be di positive, this is B tri positive, this is C plus 4. More the charge on cation, more the polarizing power, more the covalent character. So covalent character of CCl4 has to be maximum. Covalent character of CCl4 has to be maximum. Followed by what? Followed by BCl3. Followed by what? Followed by BeCl2. Followed by what? Followed by LiCl. Right? Check the answer quickly. CCl4, BCl3, BeCl2, LiCl. Absolutely. You all are perfectly right. It's option C, which is the correct answer of the question. Done and dusted. The maximum covalent character is shown by, quickly, less than 10-second question. Over here, aluminum is in tri-positive state, magnesium di-positive, cesium positive, Sn plus 2, right? More the charge on cation, more the polarizing power of cation, hence more the covalent character, right? Perfectly done. Look at this particular question. What is the correct order of decreasing ionic character? Correct order of decreasing ionic character. You know, ionic character is inversely proportional to covalent character, right? So if we get the covalent character order, reverse that order and get the ionic character order. Perfect. So my dear students, look at this particular question quickly. Over here you have got Cl negative, F negative, I negative, Br negative. Perfect. Which one has got maximum covalent character? This one has got maximum covalent character, right? That means it will have minimum ionic character. It will have minimum ionic character. So PbI2 is the one which has got minimum ionic character. PbI2, third one is the one which has got minimum ionic character. So quickly, minimum ionic character, quickly. It is option D which is saying that third one has got minimum ionic character. Am I clear? Am I clear? Am I clear? Quick. Yes? Absolutely, guys. Absolutely. Moving on to one more. Select the most ionic and most covalent compounds. Select the most ionic and most covalent compounds. Select the most ionic and most covalent compounds. Let's select the most covalent first. If you look carefully, chromium oxidation state here in CrO5. Can you let me know that? Oxidation state of chromium in CrO5. Quickly. What is the oxidation state of chromium in CrO5? That butterfly structure, if you remember. What is it? Absolutely, it's +6. Manganese here will be +7. Lead will be in +2. Iron here is in +3. Tin will be in +4. Perfect. So, which one is the most covalent? More the charge on cation, more the covalent character. So, Mn2O7 is most covalent. Most covalent, right? Now, which one is most ionic? Most ionic means least ionic. Sorry, most ionic means least covalent. Which one is least covalent among all? Least covalent will be PbO. This is least covalent. Maximum covalent, least covalent. That means this is minimum ionic. This is most ionic. So answer is going to be PbO MnO2O7. PbO Mn2O7, right? Option B is the one which is correct. All of you are perfectly right. Perfectly right, guys. Good job. Tell me the answer of this question. Increasing order of covalent character quickly. Increasing order of covalent character, people. Increasing order of covalent character. This is Na positive. This is Rb positive. This is Mg di positive. This is Al tri positive. Correct? More the charge on cation, more the polarizing power of cation, more the covalent character. Now, which one has got maximum covalent character? I believe it is the fourth one which has got maximum covalent character. We have to write them in increasing order of covalent character, right? So what has to be the answer? This is the maximum covalent and this is maximum covalent, right? Maximum covalent. Now, which one is minimum covalent? Which one is minimum covalent? Charge on these two is same. Charge on these two is same, right? Talk about size. More the size, less the polarizing power, lesser the covalent. So second has got this one. So it's option C, which is correct answer of this question, which everyone has written over here. Great job done. Which of the following set of molecules have zero dipole moment? Which of the following set of molecules have got zero dipole moment? Quickly. Quickly, guys. Everyone. Zero dipole moment. Quickly. I've told you yesterday, if you remember, Ab2L0, Ab3L0, Ab4L0, Ab5L0, Ab6L0, Ab4L2, Ab2L3. All these species, what do they show? They show zero net dipole moment, right? BF3, Ab3L0, BEF2, Ab2L0, carbon dioxide, Ab2L0, and 1,4-dichlorobenzene, it already has zero dipole moment, so it's option C, which is the correct answer of this particular question. I believe it's clear. I believe it's clear. Yes? Right, people? Tell me the answer of this question quickly. Quickly, guys. The order of dipole moment. What do you think is going to be the order of dipole moment? See, first of all, if you look carefully, BF3 has got 0 dipole moment, right? Wait. If you look carefully, BF3 has got 0 dipole moment. We have to write the increasing order, right? Increasing order. BF3 has got minimum dipole moment. Perfect. Now, among NF3 and NH3, which one has got more dipole moment? NH3 has got more dipole moment than NF3. We have discussed that. So it's directly option C. Yeah, directly option C. We have done it yesterday, if you remember. Tell me, a neutral molecule XF3 has a 0 dipole moment. The element X is most likely. Quickly. Neutral molecule XF3 has 0 dipole moment. XF3. That means it has to be BF3, right? It has to be BF3. Perfect. It has to be BF3. Guys, I want you guys to be active in the chats. BF3 has got 0 dipole moment, right? You know it. You know it. Which of the following is the polar molecule? Polar molecule. The one which has got net dipole moment non-zero. The one which has got net dipole moment non-zero is a polar molecule. Net dipole moment non-zero is a polar molecule. Now, talk about the type of this. The type of this molecule, you know, it's AB4L1. This is AB4L0. This is AB4L2. This is AB3L0. So this type 0 dipole moment. This is having 0 dipole moment. This will have 0 dipole moment. This will have some dipole moment. So it's option A, right? Which has got some dipole moment. So it is polar. Perfect. Simple. So remember those types which I told you. AB2L0, AB3L0, AB4L0, AB5L0, AB6L0, AB4L2, AB2L3. Whenever you see such kind of the molecule, their net dipole moment is 0. That means they are non-polar. Yeah. Moving ahead. Tell me the answer of this question quickly. Which of the following possesses the dipole moment? Type of this molecule. AB6L0. This one. AB2L1. This one. It is AB2L2. Correct? AB2L2. This is AB4L1 type. Which of the following molecule possesses dipole moment? See, the first one won't possess any dipole moment, right? Rest, all the three will possess dipole moment, right? Rest, all the three will possess the dipole moments. I hope you got it. Right? So basically that category is important, which I told you, the type of the molecules which show net 0 dipole moment. You have to remember those types. You need to remember those types. Tell me the answer of this question. PP overlapping will be observed in which molecule? PP overlapping will be observed in which molecule? In hydrogen, in H2 molecule, there will be SS overlapping. In hydrogen bromide, there will be SP overlapping. In hydrogen chloride, there will be SP overlapping. In Cl2 molecule, there will be PP overlapping. Right? In VBT yesterday, we have discussed how your F2 molecule is formed, N2 molecule is formed, O2 molecule is formed, right? I am moving ahead. The angle between the overlapping of 1s and 1p. If this is 1s and this is p, right? The angle of overlapping. What is the angle of overlapping here? The angle between the overlapping of 1s and 1p. What is it? 180. Discussed in detail yesterday. 180. Which of the following represents zero overlap? Same sign, same side. This is positive overlap, right? Opposite sign, same side. This is negative overlap. Is here any sort of overlap? There is no overlap here, zero overlap, right? It's C. Done and dusted. Okay. What is the correct order of bond energy? Bond energy, bond energy, bond energy. You know, yesterday I've told you, bond order is directly proportional to bond dissociation energy, directly proportional to bond strength, inversely proportional to bond length. Inversely proportional to bond length, right? Bond order means number of bonds, correct? So more the bonds, more the bond strength, more the bond energy, right? So this, and this. This is the bond energy. This is the bond energy order. Perfect. Perfect, guys. Answer this question quick. Answer this question quick. Quickly. The number of pi electrons. Let me see how many of you will mark it wrong. The number of pi electrons. Pi electrons. This is a pi bond. Pi bond, pi bond, pi bond. So how many pi bonds? 4 pi bonds. 1 pi bond formation requires 2 electrons. So there are 8 pi bond electrons here. 8 pi bond electrons here. Right? Don't write 4 or something. Perfect. Answer this one quickly. Answer this one quickly. Answer this one quickly. The molecule not having pi bond. See guys, O2 you know. In MOT we saw O2 has a double bond. N2 there's a triple bond. Carbon dioxide structure you know, right? Cl2 you know there's a single bond. Bond order is 1, right? So what is here? It does not have any pi bond, right? It does not have any pi bond. Perfectly done. Moving on. Which of the following molecules represent the order of hybridization sp to sp to sp, sp from left to right? Quick. Sorry. Quickly, guys. Kill it. Quickly. This is forming how many sigma bonds? 2 with hydrogen, 1 with carbon. 3 sigma bonds, 0 lone pair, sp2. 3 sigma bonds, sp2. 2 sigma bonds, sp. 2 sigma bonds, sp. Done? Done, people? This in the yesterday session I've told you. Which type of d orbitals are involved in sp3d2 hybridization? Quickly. Quickly, people. Which type of d orbitals are involved in the intermixing? Yesterday I've told you in detail. It's dz square and dx square minus y square. Right? Yes? Perfect. Tell me this one. Tell me about this one. AsF5 molecule is trigonal bipyramidal. The hybrid orbitals used for AS. First of all, if you look at the molecule, AsF5 we have. AsF5 we have, right? The type of the molecule is AB5L0. Hybridization is sp3d. It is S plus Px plus Py plus Pz plus dz square. Discussed in detail yesterday. Yes? Perfectly done. In which of the following molecule AX bond length is identical? Where A is the central atom, X is the surrounding atom. In which of the following? In which of the following? In which of the following? All the bond lengths are equal. Remember in square planar one, if all the atoms are same, right? Okay? Perfect, guys? Moving on. Okay, a lot of students are saying option C. Why do you think option C? Well, if you talk about PF5, for example, or PCl5, if I talk about a molecule like this, perfect, these are the equatorial bonds, this is axial, this is axial. In case of your AB5L0 molecule, axial bond lengths are greater than that of equatorial bond lengths. in case of this particular category. Remember this. Okay? Remember this. Carefully remember from now onwards. Quickly. The correct geometry and hybridization involved in XEF4. How do you do that? XEF4. XEF4. The type of the molecule is AB4L2. Right? AB4L2. Hybridization involved is sp3d2. Right? sp3d2. Perfect. The geometry, if you talk about this sp3d2, ab4l2, the shape of the molecule is square planar, right? All those things we have discussed. All those things we have discussed, right? All those things we have discussed. Perfect. So it's option A, which is the correct answer of this particular question. I'm moving ahead. The species having bond angle of 120. 120. The species having bond angle of 120. So it has to be sp2 hybridized. Trigonal planar, right? It has to be sp2 hybridized. The type of the molecule has to be ab2l0. Sorry, ab3l0. Which one is ab3l0? This is ab3l0. Done, understood. Yeah? Perfect. In case of water, my dear students, in case of water, the bond angle is 104 degree 5 minutes. It has to be 109 degree 28 minutes. What is the reason for that? What is the reason for that? Quickly let me know in the chats. In water, the bond angle is 104 degree 5 minutes, but it should be 109 degree 25 minutes, right? What is the reason for the decrease in bond angle? It is the lone pair repulsions which happen there in case of water. Okay? What do you think about this one? Quickly, in the chats. I'm looking at your chats only. I am looking at your chats only. Quickly. Quickly, people. Everyone. This is simple. This is simple. It's pretty much simple. Select the correct statements regarding the shape of PCl5. Shape of PCl5. PCl5 is AB5L0, trigonal bipyramidal, right? BRF5. It is AB5L1. It is square pyramidal. It is square pyramidal. One more is IF7. IF7 is, the type is AB7L0. It is pentagonal bipyramidal. Now select the answers. Select the correct statement. All are square pyramidal? No. All are trigonal bipyramidal? No. One of the given compound is square pyramidal? Yes. Right? Done? Done, people? All right. All right. Perfect. Perfect. Which of the following molecules has more than one lone pair? More than one lone pair. Sulfur has got one lone pair over here. XCF2. Xenon has got 3 lone pairs. Silicon, no lone pair. Carbon, no lone pair. Right? Which of the following pairs has more than one lone pair? It is option B, which is the correct one. Correct? Absolutely, guys. All of you are perfectly right. That means you have understood the chapter. That means you have understood the chapter. That's great. That is great. XEF2 is isostructural with XEF2. XEF2 is isostructural with XEF2. Type of the molecule is AB2L3, right? Hybridization is sp3d. Hybridization is sp3d. Look at ICl2 negative. Look at ICl2 negative. Type of this molecule is also what? AB2L3. Hybridization here also is sp3d. Perfect. So they must be isostructural. They must be isostructural. They must be isostructural. Yes, they must be isostructural. Which of the following is correct? SO3 dinegative. SO3 dinegative. Let's write the type of the molecule. Type of the molecule is AB3L1. Right? NO2 negative. NO2 negative. AB2L1. ClO4 negative, Ab4L0, NH3, Ab3L1. Which of the following is correct? Well, Ab3L1. First of all, SO3 dinegative, Ab3L1. Is this going to be tetrahedral? Which one is going to be tetrahedral? Ab4L0 is tetrahedral, so ClO4 negative is tetrahedral here. Yes. Perfect. Which is not applicable to TeCl4. Te is your group 16 element. Te is your group 16 element. Quick. Quick, people. Quickly in the chats. Done? TeCl4. The type of the molecule is Ab4L1. Is it going to be tetrahedral? Is it going to be tetrahedral Ab4L1? It is seesaw shaped. It is seesaw shaped, right? So, which is not applicable? Not applicable means tetrahedral in shape. Option B is the one. I hope it's clear. I hope it's clear. What about this one? In the structure of ClF3, the number of lone pairs of electrons on central atom. In case of ClF3, the type of the molecule is Ab3L2, right? Ab3L2. So there are two lone pairs. There are two lone pairs on the central atom. Yes? There are two lone pairs on the central atom. Perfect. All right. What about this one? What about this one? What do you think about this one? Water has positive value of net dipole moment, BF2 has 0. Why is that? Why is that? Because BF2 is linear, water is bent. Right? BF2 is linear and water is bent. Correct? BF2 is linear and water is bent. Okay. Where are the options, by the way? Okay, identify the wrongly matched. Identify the wrongly matched. Identify the wrongly matched. Identify the wrongly matched. Quick, quick. Absolutely, option 2. NH3 is pyramidal. It is not planar. It's pyramidal. Yeah, it's pyramidal. It's pyramidal. Which type of hybridization of xenon is involved in XeOF4 molecule? XeOF4. XeOF4. Valence electrons, 8. Sigma bonds, 4 plus 1, 5. Lone pairs, 1. Right? Type of the molecule, Ab5L1. Hybridization, sp3. Okay, steric number is 6. Hybridization is sp3d2. Okay, done? Done, people? Which pair of compounds is isoelectronic and isostructural? Isoelectronic, isostructural. Isoelectronic. Get the type of every molecule. Get the type of every molecule. If you look at this particular one, its type is Ab2L2. Right? Ab2L2. Ab2L2. This is Ab2L3. So type is different, so they cannot be isostructural. They cannot be isostructural. They cannot be isostructural. Yeah? What is the answer here? Get the type. IBr2 negative. IBr2 negative. It is Ab2L3 type. This one is also Ab2L3 type. So type is same, so they are supposed to be isostructural. They are supposed to be isostructural. Yes? Guys, I want you guys to be active in the chats, by the way. I want you all to be active in the chats. What do you think about this one? What do you think about this one? In which of the following species the central atom has the type of hybridization which is not the same as present in other three? Which is not the same as present in other three. First of all, get the type. Type of this molecule is AB4L1. Steric number is 4 + 1, 5. sp3d. This is AB2L3 type. sp3d. What is SB? What is SB? What is SB? It's antimony, right? It is antimony. Perfect. The type of the molecule will be AB5L1. AB5L1. And you know AB5L1, the hybridization will be sp3d2. This will be sp3d. Kill it. Kill them. Yeah? Quickly. This is the recent JEE mains question. This is the recent JEE mains question. Kill it. Identify the correct hybridization of NO2 negative, NO2 positive, NH4 positive. What do you think? What do you think about this one? Again, you should be in a position to solve this question. If you talk about NO2 negative, get its type. The type of this one is AB2L1. NO2 positive. NO2 positive. Get the type of the molecule. And you know how do we get the type? Guys, do you remember how do we get the type of the molecule? Just tell me that first. Do you remember that? How do we get the type of the molecule? Do you remember how do we get the type of the molecule? I'm asking you quickly. Say it, yaar. Do you remember how do we get the type of the molecule? Someone is asking how to find the lone pair. Watch the yesterday's session. You'll get to know. Perfect. Look at this one. This is AB2L0. NH4 positive. This is AB4L0. Hybridization. 2 sigma 1 lone pair. 2 + 1 3 sp2. 2 + 0 2 sp. Right? And this is sp3d. Now, what is the answer? You can easily check it. Yeah? Perfect. What about this one? What about this one? What about this one? Which of the following structure is most stable? Most stable. We are basically given with ClF3 molecule, right? We are given with ClF3 molecule. If you look at the ClF3 molecule, the structure, the type will be AB3L2 and it has to be T-shaped. It has to be T-shaped. Discussed yesterday. It has to be T-shaped. Discussed in yesterday's marathon. Which one is T-shaped? It's option A. Right? It is option A. Perfect. It has to be T-shaped. Correct? ClF3, 3 sigma bonds, 2 lone pairs, right? 3 sigma bonds, 2 lone pairs. It has to be T-shaped. T-shaped structure is the one wherein it has got minimum repulsions and maximum stability. So only one. Only one. Okay, this question is tricky. Can you let me know the answer of this one? Give it a try. Let me see what you will think about this one. Quick. This is Quickly. What do you think? What do you think? What do you think? See guys, this is XeOF4. First of all, let me tell you, answer is 0. Why? Have a look. This is the structure. This is the structure. This is the structure. This is the structure. Lone pair is present at the axial position. Perfect. This lone pair, it exerts between this lone pair and these bond pairs. There will be repulsions. There will be repulsions, due to which this plane, I mean the bonds which were present on this plane, right? They'll slightly bend downwards. They'll slightly bend downwards. They'll slightly bend downwards. They'll slightly bend downwards. You got it? Due to the repulsion between lone pair and bond pair. Perfect? Due to the repulsion between bond pair and lone pair, there'll be no angle which will be 90 degree here. Remember this particular case. It's a special case. Okay? Remember it. Quick. What do you think about this one? What do you think about this one? Which of the following species have same hybridization? Same hybridization as that of carbon in CH2CH2. In CH2CH2, carbon has got sp2 hybridization. Now, where do you see sp2 hybridization? Where do you see sp2 hybridization? Where do you see sp2 hybridization? Quickly. If you talk about the first one, let me show you it over here. CO3 di-negative, right? Valence electrons of carbon are 4. There's a negative charge, 4 plus 2, 6. Sigma bonds are 3. Sigma bonds are 3. Now, is there any lone pair? Oxygen is divalent. So consider 2 bonds. So 3 2s are 6, 6 bonds. So all the 6 valence electrons have been, understand it? They have been used. So lone pair, 0. Steric number 3 plus 0 is 3. Hybridization is sp2. Yeah? Hybridization is sp2. Which of the following species is not expected to exist? Does not exist. Which species does not exist? The one? Which species does not exist? The one whose bond order will be less or equal to 0. The one whose bond order will be less or equal to 0. Less or equal to 0. Which one is that? Which one is that? Which one is that? Which one is that? Quick. You have to write the molecular orbital configuration if you remember. Right? After writing the molecular orbital configuration, you have to calculate the bond order. If the bond order comes out to be less or equal to 0, the molecule does not exist. And look at the configurations. If you write the molecular orbital configurations, the way I showed you in the yesterday's marathon, right? If you write the molecular orbital configurations, B2, right? B2 has got 4 bonding electrons and 4 anti-bonding electrons. So 4 minus 4 divided by 2 comes out to be 0. Yes? Right? Which of the following does not exist? Again, the similar type of question. Again, you'll be writing the molecular orbital configuration. Again, you'll be writing the molecular orbital configuration. Right? If you talk about He2, there are total 4 electrons. Its molecular orbital configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, right? So how many bonding electrons are there? 4 bonding, 4 anti-bonding. 4 bonding, 4 anti-bonding. Bond order will be 0. Bond order will be 0. 4 bonding, 4 anti-bonding. Bond order will be 0. Right? Yeah? Perfect. So bond order is 0 in the 4th case. Which of the following is paramagnetic? This sort of a question I told you yesterday, if you remember. How do we check whether the species is paramagnetic or diamagnetic? Write the molecular orbital configuration. If there is the unpaired electron, If there is an unpaired electron, it's paramagnetic. If you write the molecular orbital configuration of O2, there'll be two unpaired electrons. There'll be two unpaired electrons. Have a look. These are the two unpaired electrons. One in this and one in this. Right? One in pi star 2px and one in pi star 2py. So there are two unpaired electrons. So it has to be paramagnetic. It has to be paramagnetic. Right? It has to be paramagnetic. Total number of anti-bonding electrons present in O2 will be. Total number of anti-bonding electrons present in O2 will be. Total number of anti-bonding electrons present in O2 will be. Again, you will have to write the molecular orbital configuration. After writing the molecular orbital configuration, now you have to calculate the anti-bonding electrons. 2, 4, 5 and 6. So there are 6 anti-bonding electrons. Total 6 total anti-bonding electrons present in what? Present in O2. I believe it's clear. When you convert O2 into O2 negative, how do you convert O2 into O2 negative? How do you do that? You give 1 electron to O2. You give 1 electron to O2, it gets converted into O2 negative. It gets converted into O2 negative. Now, where that electron goes, in which molecular orbital that electron goes? In which molecular orbital that electron goes? That electron goes to pi star 2px molecular orbital, right? That goes to pi star 2px molecular orbital. This is the molecular orbital configuration of O2. Now the extra electron, one more electron will go here. Then one more electron will go here. Got it? Perfect. I hope it's clear. I hope it's clear. This question, yesterday I told you. Which of the following diatomic molecule species has only pi bonds? Only pi bonds. This is discussed yesterday. O2, 1 sigma 1 pi, 1 sigma 2 pi. Both are pi here. Both are pi here in C2. Right? This was explained by MOT, if you remember. Which of the following pair of species have same bond order? Isoelectronic species have got same bond order. Isoelectronic species. Carbon, 6 electrons, 7 electrons. 7 plus 6 plus 1, 14. So 8 plus 6, 14. Isoelectronic species. Bond order same. Isoelectronic species. Bond order same. The common features among the following species. Cn negative, CO, NO positive. What do you think? What do you think? Cn negative, CO, NO positive. Cn negative. Cn negative. 7 plus 6 is 13 plus 1. This is a 14 electron species. This is a 14 electron species. This is the 14 electron species. So first of all, they are isoelectronic. And isoelectronic species have got same bond order. Isoelectronic species have got same bond order. And you know, 14 electron species, they have got the bond order of 3. 14 electron species, all the 14 electron species, they'll be having bond order of 3. Right? For you're given with following species, correct order of their bond order. Correct order of their bond order. One trick I gave you yesterday, if you remember. 14 electron species, they have got bond order of 3. 15 electron species, 2.5. 16 electron species, 2. 17 electron species, what? 1.5. 18 electron species, what? 1. 13 electron species, 2.5. 12 electron species, 2. 11 electron species, 1.5. 10 electron species, 1. Right? Now O2. O2 is 16 electron species. O2 is 16 electron species. O2 positive is 15 electron species. Right? O2 negative is 17 electron species. And O2 di-negative is 18 electron species. Now arrange them on the basis of their bond orders. Done? Simple. Arrange them on the basis of their bond orders. We are done here. Okay? We are done here. We have to write the order of what? We have to write the order of bond dissociation energy. We know bond order is directly proportional to bond dissociation energy. So calculate their bond orders. Bond order of N2 is 3. Bond order of N2 is 3. Bond order of O2 is 2. Bond order of O2 negative. Bond order of O2 negative will be 1.5. Perfect. Whatever is the order of bond order, same is the order of the bond dissociation energy. Perfect. This N2 greater than O2 greater than O2 negative. Perfect. Guys, I want you to be active in the chats. You have to solve the questions in very, very lesser time, by the way. A relationship between the bond dissociation energy of N2 and N2 positive. N2 and N2 positive, right? Here the bond order is 3 and here the bond order is 2.5. So bond dissociation energy here will be more. Simple. More the bond order, more the bond dissociation energy. That's all. Yeah, that's all. That's all. Okay? Done? Just a second. These are the repeated questions here. Just a second. Okay. Electrovalence of calcium. Electrovalence of calcium and chlorine. One simple and basic question which all of you can solve easily. Electrovalence of calcium and chlorine. What do you think? Calcium, it belongs to group 2. So 2 electrons in their outermost shell, right? Chlorine, group 17, 7 electrons in its outermost shell. Electrovalence of calcium and chlorine are calcium is group 2, so it will show +2. Chlorine is group 17, it will show -1. So +2 -1 is the answer. +2 -1 is the answer. In N2 molecule, the number of electrons shared by each nitrogen atom. In N2 molecule, the number of electrons shared by each. Guys, we'll complete the session in very lesser time, okay? You know what kind of speed we are having to solve the questions. I think till now we have solved almost like 80-90 questions in less than an hour. Perfect? Right? So don't worry, I'm not going to exceed the session. I'll finish it quickly as soon as possible. But I want your support in the chats continuously. So let's keep this session short and crisp only. Let's complete, because whatever, see, I don't need to explain anything here, because all the things are explained in the yesterday's session. I would explain the same things again. Yeah? So let's be quick, let's be very fast. Let's try to solve the questions in less than 10 seconds. Okay? In N2 molecule, the number of electrons shared by each nitrogen atom. 3. Right? Discussed. Among the following, the electron deficient compound. Electron deficient, quickly. Electron deficient. BCl3, boron has only 6 electrons in its octet, in its outermost shell. It should have 8. Yeah? It should have 8. It should have 8, but only 6. So deficient. Kill it. Which of the following is electron deficient? I told you right now, few minutes back, BH3, right? So this is electron deficient. NEET 2013. Okay. Which of the following does not follow the octet rule? PCl5. PCl5. So it has got 10 electrons in its outermost shell, right? The octet rule is failed here. It should have 8. Done? This question has been asked 2 times. You are given with 3 species, sorry, O2, then you have got O3, then you have got H2O2. H2O2 means O2 dinegative, right? O2 is a 16 electron species, this is a 18 electron species. 16 electron species, its bond order is 2, 18 electron species, its bond order is 1, right? Its bond order is 1. Perfect. And its bond order. In O3, there will be resonance. Bond order lies between 1 and 2. It lies between 1 and 2. Perfect. So, you know, bond order is inversely proportional to bond length. Right? So, which one has got least bond order? This has got least bond order, so maximum bond length. So, O2 dinegative will have maximum bond length. Followed by O3. Followed by O2. This is the bond length order. Right? This is the bond length order. Is it done? Is it done, guys? Is it done? I believe it is. Okay. I'm moving ahead. What about this question? Look at the question carefully. Look at the question carefully. Ionic bonds will be formed more easily if metal has low ionization energy and non-metal has high electron affinity or electron gain enthalpy. Yesterday I told you. Yesterday I told you that. So what is the answer? Metal should have low ionization energy and non-metal should have high electron affinity. Perfect. So it's option B with the answer. Tell me the isoelectronic set of species among all. Isoelectronic set which have got same number of electrons. Same number of electrons. Same number of electrons. N trinegative. 7 plus 3, 10. 8 plus 2, 10. 9 plus 1, 10. 11 minus 1, 10. So these are isoelectronic species. These are isoelectronic species. Which of the following has highest lattice energy? Lattice energy. If you remember yesterday I've told you. Directly proportional to charge. Inversely proportional to size. Directly proportional to charge. Inversely proportional to size. Charge everywhere is same. F negative, K positive. F negative, Na positive. Charge everywhere is same. Charge everywhere is same. Now decide on the basis of size. Lesser the size of cation, more the lattice energy. Na positive has got lesser size among all these cations, so maximum lattice energy. Yeah? Maximum lattice energy. What about this one? Which of the following bond have got highest ionic character? HI, HF, HCl, HBr. Look at the electronegativity difference. Where is the electronegativity difference more? In the second one. More the electronegativity difference, more the polar nature. More the covalent character. More the ionic character. Right? More the ionic character. Which of the following pairs will form most stable ionic compound? Stability of ionic compound depends on lattice energy. Stability of ionic compound depends on lattice energy. And lattice energy depends on charge and size. Charge and size. If Na and Cl mixes, it forms NaCl. This forms MgF2. This forms LiF. This forms NaF. Right? Now, which one has got maximum lattice energy? Look at the charge. +1, +2, +1, +1. This has got maximum lattice energy. Maximum lattice energy means maximum stability. So MgF2. Right? MgF2. I believe I'm clear. I believe I'm clear. Well, these questions we have solved yesterday, if you remember. I'm not going to solve them again. These questions we have solved. These set of questions also we have solved yesterday. What about this one? This you already know. The molecule which has zero dipole moment is BF3, right? The molecule which has zero dipole moment, it is BF3. Okay? The molecule which has dipole moment, carbon dioxide linear, no dipole moment. P-dichlorobenzene, right? No dipole moment. CH4, no dipole moment. Only NH3 is the one which has got the dipole moment. These are some simple questions, basic questions. Which of the following is non-polar? This is polar, this is polar, this is polar, this is polar. H2 only is non-polar because electronegativity difference is 0. Just a second, guys. These are some repeated questions which I have solved already. This you should be able to answer quickly. This you have to, I mean, you know it already, right? Yesterday I told you in detail. Lone pair repulsions are maximum, followed by lone pair, followed by bond pair, right? Perfect. the shape of ClO3 negative ion. Shape of ClO3 negative ion. Quick. The shape of ClO3 negative ion as per VSEPR is. Quick, guys. Be very quick. Be very quick. Be very quick. The shape of ClO3 negative ion. It is. Which one is it? The type of the molecule is AB3L1, which has to be pyramidal. Right? Which has to be pyramidal. So option B is the one which is correct. Guys, am I going very fast? Or it's fine? Just tell me in the chats. Am I going very fast? Or you're liking it? See, all these things we have discussed yesterday, right? All these things we have discussed yesterday. So I'm not explaining things. We are trying to solve the questions in lesser time, right? Because if it was physical chemistry, then I don't know. I think till now we have solved some 100 questions. If it was 100 questions of physical chemistry, then it would have taken like 4 hours. You know it. Perfect. Chalo, you are loving it. That's great. Quickly, which of the following? In which of the following bond angle is maximum? Bond angle is maximum. Quickly. Bond angle is maximum. Quick. Quick, quick, quick. Quick. Quickly. It is option C. sp3 geometry. sp3 tetrahedral 10928. 10928, right? In all the others, it will be less than that. In all the others, it will be less than that. Because of the presence of the lone pairs. Because of the presence of the lone pairs. Order of the lone pairs. Order of the lone pairs on the central atom. Quick. XeF2. Xenon has got 3 lone pairs. Chlorine has got 2 lone pairs. Iodine has got 1 lone pair, 0 lone pair. Right? Done? Done, people? Yeah? A molecule has 2 lone pairs. A molecule has 2 lone pairs and 2 bond pairs around central atom. Right? Around central atom. The molecule shape is? It is AB to L2. AB to L2. AB to L2. VSEPR. V-shaped. Right? Yeah? What about this one? Wait, guys. Square pyramidal shape. Square pyramidal. Square pyramidal means AB5L1. 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 Yes? Dusted? ClF3, number of lone pairs on central. ClF3. 2 lone pairs on chlorine. Right? 2 lone pairs on chlorine. NEET 2017. I think we have solved this question already. Today only we have solved. Option was 2. right? AB to L3, AB to L3. We have solved this question already. Okay, I believe a lot of students will mark this question incorrectly. Why do I feel so? Why do I feel so? That's why I told you a lot of students will mark it incorrectly. He's not asking about the lone pairs on central atom. He's asking about the total number of lone pairs. He's asking about the total number of lone pairs. See, we already know in case of I3 negative, it is of the type AB2L3. I hope you remember. This, for example, iodine, right? There's a lone pair of the central iodine, lone pair of the central iodine, lone pair of the central iodine. There's one more iodine here. This is one more iodine here, right? Perfect. This is the structure. No doubt this particular iodine has got 3 lone pairs. This also has 3 lone pairs. This also has 3 lone pairs. So in total, how many? 3, 3, 9, 3, 3, 3, 6, 3, 9. So in total, there are 9 lone pairs in the molecule. If he had asked about the total lone pairs on the central atom, then the answer was 3. He's asking only about the total lone pairs. So you see how do they play with you? With small kids? Not good, right? Okay. Quick. A sigma bond in molecule MX3. MX3 is T-shaped. T-shaped. Just understand. T-shaped has to be, the type has to be what? T-shaped. The type has to be AB3L2. AB3L2. The non-bonding electrons. Non-bonding means lone pair. 2 lone pairs. Yes? Done. Which species has got pyramidal shape? Pyramidal shape. Pyramidal shape. Pyramidal shape. Quick. Remember, it's a special case. It is OSF2. OSF2. It is a special case. Guys, how come this is pyramidal? This won't be pyramidal, right? This has 2 lone pairs. This is not pyramidal. When this is not pyramidal. It is OSF2 basically here, which is pyramidal among all. Okay? This is not osmium. This is not osmium. O stands for oxygen, S stands for sulfur here. Right? Perfect. Shape of methane molecule is, tetrahedral. Leave it. Can you see the graph? Energy versus internuclear distance, this graph we have seen. Look at the following curve. Which of the following correctly represent the most stable state of hydrogen molecule? Most stable state. Most stable state. Quick. Most stable state. Where is the most stable state? Most stable state. Potential energy minimum. Potential energy minimum. Stability maximum. Right? du by dr is equal to 0. Yesterday we have discussed at this point. Perfect. Where do I get more questions from bonding? I think bonding is all about it, right? Achha, one more. O3 molecule, the number of sigma and pi. This has been frequently asked, this question, okay? In case of O3 molecule, how many sigmas are there? How many pi are there? Remember this one. There are 2 sigma and 1 pi bond in O3. Let me see some assertion-based questions. Okay, one question, which is for everyone. This I would have taught you in GOC, if you have seen my GOC lecture long back. As the S character of the hybrid orbital increased, the bond angle is directly proportional to electronegativity. Electronegativity is directly proportional to percentage of S character. It increases, right? Perfect. I hope you remember this. As the bond angle increases, S character also increases. Electronegativity also increases. Okay. What is the shape of sulfate ion? SO4 dinegative. Shape of sulfate. SO4 dinegative. Quick. Shape of sulfate. SO4 dinegative. Everyone. Shape of sulfate. SO4 dinegative. Quick. SO4 dinegative. It is? Quick guys. SO4 dinegative. Right? Valence electrons of sulfur are 6 plus 2 makes it 8. Right? Sigma bonds are 4. Sigma bonds are 4. Lone pairs are 0. Type AB4L0. AB4L0 tetrahedral. Correct? AB4L0 tetrahedral sp3. I think you've already seen the answer here. I think you've already seen the answer. Which of the following molecule does not have the linear arrangement of atoms? C2H2. C2H2. SP, linear. BeH2. BeH2. SP hybridized, linear. Carbon dioxide. Carbon, SP hybridized, linear. So all these are linear. H2S. Type of the molecule is AB2L2. AB2L2 means it is V-shaped. It is V-shaped. Correct? It is V-shaped. It is V-shaped. Tell me the answer of this question. Very quick. Tell me the answer of this particular question very, very, very quick. Quickly, guys. Quickly. SP3. 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 The question is saying in which of the following species is the underlined carbon having SP3 hybridization, right? Quickly, I would want the answers in the chats. Everyone. It's a very simple and basic question, right? It is a very simple and basic question. My dear students, over here, if you look at this particular underlined carbon atom, it is basically C double bond OOH, right? It is basically C double bond OOH. So how many sigma it's forming? 3 sigma, and 1 pi. So it cannot be sp3. Look at this particular one. It is CH3, this is CHH, right? And this is OH. This is forming 4 sigma bonds, so it's definitely sp3. It is definitely sp3, right? So the correct answer of this particular question has to be option B. Look at this one. As I told you in the last session, the number of atomic orbitals combined is always equal to the number of hybrid orbitals formed, right? Is always equal to the number of hybrid orbitals formed, right? But over here, the answer is not in terms of hybrid orbitals. It's in terms of molecular orbitals. Again, I told you in the last session, as the number of atomic orbitals combining is equal to the number of molecular orbitals formed, out of which few are bonding and few are anti-bonding, right? So 2 molecular orbitals are formed here. Perfect. The bond order of N2 positive. N2 positive is a 13 electron species. Its bond order has to be 2.5, right? Its bond order has to be 2.5. H2 positive and H2 negative. H2 positive and H2 negative. H2 positive and H2 negative. Quick. Quick, guys. H2 positive and H2 negative. Which one is more stable? What do you need to do? You need to write the molecular orbital configuration. You need to write the molecular orbital configuration. Yeah? Majority is saying option C. It is option D. It's option D. If you calculate the bond order of H2 positive, it comes out to be 1 by 2. Bond order of H2 negative is also coming out to be 1 by 2. But in case of H2 negative, there is antibonding electron. Here you do not have any antibonding electron. More the antibonding electrons means lesser the stability. So H2 negative. H2 negative is less stable than H2 positive. So H2 positive is more stable. H2 positive is more stable, right? Perfect. I've told you in the last session, if you remember, if bond order of two species is same, then look at the antibonding electrons. More the antibonding electrons, lesser the stability. Yeah? What about this one? What about this one? Quick. What about this particular question? What about this particular question? We are talking about O2 positive, right? O2 positive is the 15 electron species. 15 electron species have got bond order of 2.5, right? So bond order 2.5. 16 electron species has got bond order of 2. 16 electron species is your O2. This is your O2 positive. So O2 positive have got bond order greater than O2. So bond order is greater than O2. Bond order is greater than O2, right? Now, in case of O2 positive, in case of O2, there are two unpaired electrons. Here there will be only one unpaired electrons. Here there are two unpaired electrons. Here there will be only one unpaired electron. One unpaired electron means paramagnetic, right? So it has to be option B. Correct? It has to be option B. Which of the following has got minimum bond length? Calculate the bond order. First of all, this is 15 electron species. Sorry, this is 15 electron species. This is 17 electron. This is 18 electron. This is 16 electron. 16 electron species have got a bond order of 2. 17 have got 1.5. 15 have got 2.5. 18 have got 1. You know your bond order is inversely proportional to bond length. Which of the following is minimum bond length? For the bond length to be minimum, bond order has to be maximum. Where is the bond order maximum? In the first one. So answer is A. Yes? Perfect. NEET 2019. Which of the following is paramagnetic? O2. Two unpaired electrons, right? Two unpaired electrons. Okay, this question I believe you would have studied in GOC as well. Intramolecular, within the molecule. Within the molecule, intramolecular hydrogen bonding is present in orthonitrophenol. You should be knowing this, right? Yes, within the molecule. What do you think about this one? Can you look at the question? The vapor pressure of this is higher than this. Do you know? Vapor pressure of first one is higher than the vapor pressure of second one. What is the logic? What is the logic? What is the reason? I can see majority is coming up with option C, and you are absolutely right. It's option C. One more. Acetic acid exists as a dimer. That means two acetic acid molecules, they are forming one, right? Okay. Acetic acid exists as dimer in benzene. Why is that? Why is that? Why is that? Because of hydrogen bonding. Because of hydrogen bonding. Yes, because of hydrogen bonding. Which of the following compound possesses the highest lattice energy? Charge everywhere is same. Talk in terms of size. Lesser the size, more the lattice energy. Li positive has got least size among all these cations. Maximum lattice energy. Option 1. Option 1. Option 1. Which of the following has got maximum dipole moment? Maximum dipole moment. This sort of a question yesterday we have solved. I want you guys to give it a try. And let me know in the chats quickly. Quickly. Maximum. See, first of all, this is Cl, electron withdrawing, so negative, positive. This direction, this is the direction, this is the direction. These two, they are at an angle of what? 120. If this is x, this is x, this is x. Now this one and this one, they are at an angle of 120. So the resultant will go in this direction. That will be x. X plus x makes it 2x. Right? This one cancelled out, only x. Perfect. The resultant of these two will be in this direction. Net is 0. Net is 0. Option 2. Yeah? Option 2. Option 2. We have discussed all this stuff yesterday. The number of molecules with non-zero net dipole moment. How many species are there which have got net dipole moment to non-zero? Non-zero. Quick. I've told you already the set of molecules which shows you zero dipole moment, right? AB2L0, AB3L0, AB4L0, AB5L0. Let's check it out. BF2. If I talk about BF2, it is AB2L0. This is AB3L0. This is AB2L2. This is AB3L1. This is AB4L0. And HCl, we know it's already polar, right? What do we have to see? The number of molecules with non-zero. This is the molecule with non-zero, right? This is the molecule with non-zero. This is the molecule with non-zero. So 1, 2, and 3. There are 3 molecules which show non-zero, right? Perfect. I believe it's all clear to everyone. Tell me the answer of this question. Tell me the answer of this question. Which of the following overlap is incorrect? Incorrect. If Z is the internuclear axis, this is Z, for example, which is the internuclear axis, right? This is Z. Now, Py and Py. This is, for example, your Py. If this is Z axis, then let's call this as Py. Py and Py, they are going to form pi bond. So 1 is correct. X and X. If this is Z, this will be X and this will be X. X and X, what do? They do parallel overlapping, right? Parallel overlapping means pi bond. So this is incorrect. Perfect. If Z is the internuclear axis, Z is internuclear axis. We have got Z as the internuclear axis. Now, 3dxy, 3dxy. 3dxy, 3dxy. Right? If this is Z, then xy plane is this. My hand is xy plane. This xy plane. So 3dxy, 3dxy. There'll be 2-lobe interaction or 4-lobe interaction. See, this is 2-lobe interaction. This is 4-lobe interaction. 4-lobe interaction means delta bond. 2-lobe interaction means pi bond. Right? So over here, 3dxy will show 4-lobe interaction. They'll form delta bond. So this is wrong. 2s2p. 2s2p. 2s This is S and this is P. What will happen? Bond formation? Nope. 3dxy, 3dxy. They are going to form delta bond. 2pz, 2pz. If this is z-axis, if this is z-axis, this is your 2pz, this is 2pz. It's head-on overlap, sigma. This is right. Right? So how many are wrong? 2, 3, 4. 2, 3, 4 is the answer. Right? I believe I'm all clear. Okay, fluorine molecule is formed by, yesterday we have seen in VBT, fluorine molecule. It's formed by PP overlap, PP head-on overlap, PP end-to-end overlap. Right? PP end-to-end overlap. This is discussed already. The sp2s, the sp2s sigma bond, the sp2s sigma bond in benzene. In benzene, all the carbon atoms are sp2. So sp2 hybridize, sp2, 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 sp2. So there is an hybrid orbital here. Hybrid orbital, hybrid orbital, hybrid orbital, as well as hybrid orbital, right? Now, one of the hydrogen will come from this side, right? One from this side, one from this side, one from this side. So this overlap is sp2s, sp2s, sp2 hybrid orbital of benzene, sp2 hybrid orbital of carbon, and s orbital, pure s orbital of hydrogen. So this is sp2s. So how many? 1, 2, 3, 4, 5, 6. So 6 sp2s. Okay, 6 sp2s. In which of the following molecule dz square orbital must not be involved in bonding? dz square. dz square. In pentagonal planar, hybridization will be anyways what? Pentagonal planar, sp3d2. Pentagonal planar means AB, pentagonal planar. Okay, wait just a second. What is going to be pentagonal planar? Like your square planar. It is AB5L2. 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 5 plus 2, 7. State number 7. sp3d3. dz square is involved there. dz square is involved there. In case of linear, is dz square involved? Linear, it can be AB2L3. AB2L3 is linear, right? AB2L3 is linear. Be careful with this. AB2L3 is linear. Perfect. Hybridization sp3d, dz square is involved. Square planar, sp3d2, dz square is involved. Only trigonal pyramidal is there, right? Trigonal pyramidal is there, AB3L1. AB3L1, hybridization is sp3. That is the only one wherein dz square is not involved. So option 2 is the one which is correct. Option 2 is the one which is correct. The maximum number of 90-degree angles between bond pair of electrons is maximum number of 90 degrees. This question also I've told you yesterday. Maximum 90 degrees between bond pair. It has to be what? Between bond pair. It has to be sp3d2, right? Octahedral, wherein there are 490 degrees between bond pairs. Right? Perfect. Perfect, guys. Sorry, this is like this. Just a second. I don't know what I was thinking. This is your octahedral geometry. Perfect. This is B. This is B. In this equatorial plane, how many 90 degrees are there? This is 1, 2, 3, 4, right? So in the equatorial plane, there are 490 degrees. Perfect. This bond is forming 490 degrees from top. This bond is forming 490 degrees for bottom. So in total, there are 1290 degrees, right? So, perfect. They are not asking about axial or axial equatorial or equatorial. They're asking about general bond pair, right? It is 90 degree. Perfect. It is 1290 degrees basically. If you remember yesterday, I've told you the same thing, right? We discussed all this in detail yesterday. Quick. Quick, guys. Hybridization of the central iodine in IF5. In IF5. In IF5. AB5L1. sp3d2. AB2L3. sp3d. I3 positive can be written as I2 positive. Valence electrons of this iodine is 7 minus 1, 6. Sigma bonds are 2. Lone pairs are 2. Type is AB2L2. Hybridization is sp3. Correct? Done? These are here the similar type of questions. Just a second. What is the answer of this question? What is the answer of this question? You know, till now we have solved 200 questions, by the way. Till now we have solved 200 questions. What is the answer of this one? Quick, guys. Quick, quick, quick. Is it done? Non-pyramidal, the ones which are not pyramidal. SO3, AB3L0, it is pyramidal. NO3 negative, AB3L0, it is pyramidal. PC, wait, non-pyramidal I mean, okay? Non-pyramidal. This is non-pyramidal, this is non-pyramidal. This is AB3L1, this is pyramidal. Okay, and this is AB3L0, clear, non-pyramidal. So there are 3 species which are non-pyramidal basically. There are 3 species which are non-pyramidal basically. Okay. What do you think should be the answer of this question? What do you think is the answer of this question? Quick. Quick. First of all, psi A plus psi B, psi A plus psi B. That means constructive interference. Bonding molecular orbital. Constructive interference, bonding. Psi A minus psi B, destructive interference, anti-bonding. Perfect. Q multiplied by R, dipole moment. Bond order, NB minus NA by 2. Yeah? Perfect. Tell me the answer of this one. Of the following species, NO, NO positive, NO2, di positive, NO negative. The one with minimum bond strength. Minimum bond strength means minimum bond order. 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 Quick. NO negative. How many total electrons? 8 plus 7, 15. 51, 16. 16 electron species. 8 plus 7, 15, 15 minus 2, 13 electron species. 8 plus 7, 15 minus 1, 14 electron species. 8 plus 7, 15 electron species. Right? Bond order 2, bond order 2.5, bond order 3, bond order 2.5. So these two, which of the following has got minimum bond strength? Minimum bond strength means minimum bond order. Minimum bond order is NO2 negative. So it's NO negative here, right? It is NO negative here. Perfect. It is NO negative here. Just a second, guys. Let me check the other new questions because these are all repeated ones. What is the answer of this one? The boiling of paranitrophenol is higher than that of orthonitrophenol because because of what? Quick. Because of what? Absolutely, all of you are right. It's option C. There is intermolecular hydrogen bonding in paranitrophenol. All these questions we are done with. Now what is left? Just a second. This is done. What about this one? Which of the following is isostructural? I think you can easily solve it. Check the type. It's AB4L0. This also AB4L0. Type is same, right? So no need to check. No need to check over here. All these are same questions. Let's solve some JEE questions which have been asked. Okay, let's try to solve some JEE questions. Let me see if we can solve them or not. This question has been asked in your JEE Mains 2021. Hybridization of atomic orbitals. NO2 negative, NO2 positive, and NH4 positive. NH4 positive is directly sp3. Right? This one is what? This one is sp. This one is 5 plus 1, 6. So this is sp2. Done? sp2, sp, sp3. Option A. Yes? Now be active, guys. Now be active in the chats. Because now the questions are all your mains questions. What is the answer of this question? The number of lone pair of electrons on the central iodine. Here is mentioning central iodine. So it has to be 3, right? He's asking about the central iodine, so answer has to be what? Answer has to be 3. If it was total lone pairs on I3, then its answer was 9. SF4, SF4, AB4L1, SP3D. I have 5. 5 sigma, 1 lone pair, 5 plus 1, 6, SP3D2. NO2 negative, 2 sigma, 0 lone pair, SP. NH4 positive, SP3. What about this one? This question we already solved. If you remember, few minutes back, this question we already solved. Correct bond order sequence. Correct bond order sequence. We already solved this question few minutes back. JEE 2021. What do you think about this one? 2 lone pairs, 3 single bonds. 2 lone pairs, 3 single bonds. 2 lone pairs, 3 single bonds. AB3L2, T-shaped. AB3L2, T-shaped. Among the following linear species, it is N3 negative. No need to check, etc. Which of the following is diatomic molecule? Carbon monoxide is a 14 electron species. All the 14 electron species, they have no unpaired electrons, so they are diatomic. When you write their molecular orbital configuration, right? Stability order. Stability order. What do you need to do? Write the molecular orbital configuration. Check the bond order. The one which is more bond order, more stable. If there are two species having same bond order, then check their antibonding electrons. More the antibonding electrons, lesser the stability. Right? Option 2. The number of species below that have 2 lone pairs of electrons. That have 2 lone pairs of electrons in their central atom. 2 lone pairs of electrons in the central atom. SF6, no lone pair here. 2 lone pairs, 1 lone pair, 0 lone pair, 1 lone pair, 2 lone pairs, 0 lone pair, 1 lone pair. The number of species having 2 lone pairs. Here you have got 2 lone pairs, here you have got 2 lone pairs. So answer is 2 only. Answer is 2 only, right? Answer is 2 only. The ion that is sp3d2 hybridization. The ion that is sp3d2 hybridization. If you look at ICl4 negative, it is of the type AB4L2. Steric number is 6, sp3d2, right? sp3d2. That's what we have to check. Correct? Rest you can do on your own. You can check them up. Now, this is the question. J means 2018. Total number of lone pairs in I3 Total number of lone pair means 9. Okay? This is also the question which we solved long back. This is also J means AEEE question. The species having pyramidal shape. It is OSF2. OSF2. Okay, OSF2. Which of the following contains maximum lone pair on the central atom? On the central atom, 3 lone pairs, 1 lone pair, 2 lone pairs, 1 lone pair. So maximum here. Number of lone pairs in XeOF4. Number of lone pair on the central atom. On xenon, that will be 1. Right? If you remember that bond angle question which I showed you, how many 90 degrees are there in XeOF4? There was 0 90 degree. Right? Do you remember? There was 1 lone pair. There was 1 lone pair. This question we've already solved. This question is already solved. Okay. This question you can solve easily. SF4 means sp3d. IF5 means 5 plus 1, 6, sp3d2. NO2 positive means what? It means sp. NH4 positive is sp3. Even this is already solved. It is a solved question. Even this bond order question is already solved. Even this already done. This is already done. 2 lone pairs, 3 single bonds, T-shaped molecule. Linear species N3 negative. This is already solved again. Just a second. I think that's it, guys. Now let's start few questions of periodic classification. Periodic classification has not much of variety, by the way. Periodic classification, there is no variety. There are only few types of questions which you should know about periodic classification. There's a few questions. The actual variety was in chemical bonding. And I believe you can easily solve chemical bonding questions from now on. Okay. What is the answer of this one? I'm sorry. Outermost electronic configuration of group 13. Group 13. Group 13. It will not take more than 20 minutes. After 20 minutes, we'll end the session. You don't need to worry. Okay, let's complete it. Why to take the break? Group 13. The electronic configuration of the element of the p block, period 5, placed diagonally to the element E is. What do you think about this one? What do you think about this one, guys? Quick. Quickly. Outermost electronic configuration of group 13 element. Group 13 means boron, aluminium, gallium. Boron's outermost configuration is 3p1. Aluminium is 4p1. So he is talking about the element aluminium. So E is your aluminium, first of all. The electronic configuration of the element of the p block placed in period 5. This is period 4, placed in period 5. Diagonally to the element. Over here. Boron, carbon. Right? Perfect. Now guys, after this, silicon. Now tell me the answer. What are you waiting for? 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 This was 4p1. This will be 5p1. Right? This will be 5p2. This will be 4p2. Just a second. I think we did some mistake. Gorman. Boron is... Wait. Sorry. I did some mistake I did. Boron's configuration is 2p1, right? I wrote 3p1. This is 2p1. This is 3p1. This is 4p1. Correct? This is 4p1. Just a second. This is 2p1. This is 3p1. This is 4p1. He was talking about which element? 4p1. Perfect. He was talking about 4p1. He was talking about this gallium, not aluminium. He was talking about gallium, not aluminium. Now we have to see which one is diagonally related. Which element comes here? Which element is here? Which element is here? Is it 10? If you do not remember the elements also, see, you can do it like this. If this was 2p1, then this is 2p2. Okay, that means carbon. This was 3p1. This will be 3p2. Right? 4p1. 4p2. 5p2. So where is 5p2? Right? Got it? Perfect. All right. This sort of question you can easily solve, I believe. Easily means easily. Ionic radio of K positive, Na positive, Al tri positive, Mg di positive, or isoelectronic species. More effective nuclear charge. More effective nuclear charge means lesser the size. More effective nuclear charge means lesser the size. Right? This sort of a question we have already solved. Yeah? Perfect. Let me see some different type of questions. What is it? The set of elements that differ in mutual relationship from those of other sets. What do you think? Lithium and magnesium, they are diagonally related. They are two. This one, lithium, sodium, they are not diagonally. See, these two are diagonally related. Correct? But these two were not diagonally related. In general, the property that shows an opposite trend in comparison to other properties across the period. Across the period, electronegativity increases. Across the period, electron gain enthalpy increases. Ionization energy increases. Right? Atomic radius across the period decreases. So this is showing a reverse of what others show. So option D, odd one out. Odd one out. Odd one out. Look at this one. Look at this one. Three elements X, Y, and Z are in third period of the period table. The oxides of X, Y, and Z respectively are basic, amphoteric, and acidic. Which forms basic oxide? Metals form basic oxide, right? Your metals. Perfect, right? He's talking about group 3. He's talking about group 3. Hydrogen is group 1. Lithium is group 2. Group 3 is your sodium. Perfect. Group 3 is your sodium. Perfect. Right? Basically, metals forms basic oxides. Non-metals form acidic oxides. Non-metals form acidic oxides. And metalloids, what do they form? Metalloids form amphoteric oxides. Now, I think you can easily solve. You got the hint. You got the hint. Right? You got the hint. And X is forming basic oxide. So it has to be on the extreme left. Y is forming amphoteric oxide in the middle. Right? Acidic is formed by Z, non-metal. So atomic numbers will be like this because they belong to the same period. It is shown they are third period elements. Right? They are third period elements. I hope this is clear. I hope this is clear. In the sixth period, the orbitals are filled. In the sixth period, the orbitals that are filled. Sixth period, orbitals that are filled. Orbitals that are filled. Orbitals are filled in this manner: ns, n-2f, n-1d, right? And np. Over here, the maximum principal quantum number is 6, n is 6. If n is 6, so this is 6s, 6 minus 2 is 4s, 4f, 6 minus 1 is 5d, this is 6p. Do you see any order like this? Do you see any order like this? Option B. Remember it. Atomic number of unilunium, right? Unilunium. Correct? Sorry, anium. Sorry. Unilunium. Just a second. Right? 1 is un, 0 is nil, and 1 is un. Correct? So it's 101. So unilunium. Okay. The IUPAC symbol of the element with the atomic number of 119. 119. Uninium. Right? Correct? 1 is un. 1 is un. 9 is ENN. N. So, what is it? It is uninium. UUE. Alright, the element with Z is equal to atomic number 120, not yet discovered, will be. See, we have 118 elements till now. And that 118th element is a noble gas. That's present at group 18. That's present at group 18. Perfect. So 119 element. That will be again in group 1. 119th will be in group 1. 120 will be in group 2. So 120 will be in group 2. Group 2 means alkaline earth metals. Correct? Right, guys? The group number, the number of valence electrons, and valency of the element with atomic number 15. Atomic number 15 means phosphorus, right? He's talking about phosphorus. Perfect. Phosphorus belongs to 15th group, number 1. Right? 15th group. Valence electrons are 5. Valency is 3. So 1553. 1553. Is that done? 1553. Alright, the element having greatest difference between first and second ionization energy. Greatest difference between first and second ionization energy. Greatest difference between first and second ionization energy. What do you think? Greatest difference between first and second ionization energy. It is potassium because this is the only group first element. Perfect. In group first elements, once you remove the first electron, right, it attains a noble gas configuration. So to take one more electron out from the noble gas configuration, you need to supply more energy, right? So difference between first and second ionization enthalpy is a lot. This I believe you can easily solve. This question I believe you can easily solve. Carbon, cesium, aluminum, sulfur. The correct order of atomic radius. Cesium is at the bottom of the periodic table, right? You know it. Perfect. Lithium, sodium, potassium, rubidium, cesium. Correct? Right? So it will be having maximum radius. So cesium will have maximum radius. Cesium will have maximum radius. Right? Leave aluminum aside. Now sulfur and carbon. Sulfur and carbon. This is, for example, carbon is group 14, group 16 oxygen, and here you have got sulfur. Here you have got sulfur. Now compare. Which one will be having more size, carbon or sulfur? What do you think? Which one will have more size, carbon or sulfur? Their period is different here. Which one has got more size, carbon or sulfur? Sulfur has got more size than that of what? Than that of carbon. Why? Because in sulfur, right, there are more shells. Period number is not same, right? What is it? In general, the property that decreases and increases down the group. Electron negativity down the group decreases. Atomic radius down the group increases. I think this is the answer, right? That's what you have to check. The property that decrease and increase down the group. Yes. Okay, what about this one? What about this one? What about this one? Ionic radius. See, these are isoelectronic species, right? These are isoelectronic species. Least radius will be for F negative. Maximum radius will be for N tri-negative, right? And O di-negative is at the middle. Or did I write the reverse? No. Least. Perfect. Least. So this is the order of the radius. This is the order of the radius. N tri-negative will have maximum radius. N tri-negative will have maximum radius. So maximum radius. N tri-negative should have maximum radius. Maximum radius is how much? 1.71. Then O di-negative. Then this. Option C. Right? Option C. The first ionization potential of sodium is 5.1 electron volt. Electron gain enthalpy. The value of electron gain enthalpy, which is reverse, right? So if it is plus 5.1, it has to be minus 5.1. Simple? Simple, guys? Okay. The set representing the correct order of first ionization potential. Can you check it out? Can you check it out, guys? Quickly. Can you check it out quickly? Quickly, guys. Corrects the set representing the correct order of first ionization potential. Down the group, ionization potential decreases. So beryllium will have maximum, followed by magnesium, followed by calcium. So which one is correct? Which one is correct? Which one is correct? It is B. It is B. Which of the following has maximum number of unpaired electrons? Quick. Maximum number of unpaired electrons. Maximum number of unpaired electrons. If you look at Fe di positive, iron has got 3d6 4s2. So take 2 electrons out. It is 3d6. It is 3d6. It is 3d6. 1, 2, 3, 4, 5, 6. So 4 unpaired electrons here. Similarly, you can check the rest. This will have maximum unpaired electrons here. This will have maximum unpaired electrons here. Among us the elements whose electronic configurations are given, the one having highest ionization energy. Highest ionization energy. This is half filled. This is also half filled. 3p3, 4p3, right? So half filled configurations are more stable. To take electron out from them, you have to supply more energy. But this is 3p3, this is 4p3. This is closer to the nucleus. So this is difficult to take out. More energy is needed. This is difficult to take out. More energy is needed. What about this one? What about this one? Sodium, magnesium, aluminum, silicon. They belong to same period, right? Sodium, magnesium, aluminum, silicon. They belong to same period. On moving from left to right, ionization energy increases. Ionization energy increases. So this has to be the order. This has to be the order. This is the expected order. But is this going to be actual? No. 3s2 configuration. Here you have got 3p1 configuration. Perfect. 3s2 configuration, 3p1 configuration. This completely filled. This is filled. This partially filled. Or you can say S has got more penetration power. So to take the electron out from here, you have to supply more energy. So ionization potential of magnesium has to be greater than that of ionization potential of just a second. Yes, ionization potential of magnesium has to be greater than that of aluminum. Rest everything is same. Is there any option like this? Sodium has got least, then magnesium, but magnesium has got greater than aluminum. Perfect, which is less than silicon, right? Perfect. So this is the order. This is the order. It's absolutely option A. The hydration energy of Mg di positive is larger than. The hydration energy of Mg di positive is larger than. It will be larger than Na positive, right? Mg di positive less than this, less than this, less than this. It will be larger than Na positive, correct? It will be larger than Na positive. The correct order of second ionization potential. The correct order of second. Already you have taken one electron out. So when you take one electron out from carbon, it becomes 2p1 configuration. This becomes 2p2 configuration. This becomes 2p3 configuration. This becomes 2p4 configuration. Correct? Now you have to take one electron out from these configurations. So second will be maximum for oxygen. Second will be maximum for oxygen. Perfect. And after oxygen, it's evident it's going to be then fluorine, etc., etc. Okay? Right? I hope you got what I said. One electron here, two electrons here, 3 here, 4 here, because we have already taken one electron out. Now the second electron here has to be taken from 2p3, half-filled configuration. So second ionization potential of oxygen is more. Here the electron has to be taken out from 2p4. Here the electron has to be taken from 2p2. But this is fluorine, right? 2p4 configuration. 2p4 configuration. Here you have got more protons, right? More protons. So to take electron out from here, right, that will be difficult as compared to 2p2 configuration. That's why I told you option C is the answer. That's why I told you option C is the answer. Someone is saying option D hoga. I told you option C, still you are saying option D. Okay, you write option D in your exam. All right, electron gain enthalpy. On moving from top to bottom, electron gain enthalpy decreases. Right? On moving from top to bottom, electron gain enthalpy decreases. Right? So fluorine should have maximum, followed by chlorine, followed by bromine, followed by iodine. But due to smaller size of fluorine, the order gets reversed. Fluorine comes at the third spot. Right? And this is the actual order. This is the actual order. This is the actual order of electron gain enthalpy. Okay? This is the actual order of electron gain enthalpies. The absolute value of electron gain enthalpy of halogens. I told you ClBr, fluorine I. So option 2. The ionic radius of Na positive is this. The ionic radius of Mg di positive and Al tri positive will be. See, we have got Na positive. We have got Mg di positive. We have got Al tri positive, right? Its radius is 1.02 angstroms. 1.02 angstroms. Now, size will be maximum for this, right? So, Al tri positive's radius has to be the least. Which is the least one? Which is the least one? 0. This has to be least. This has to be comparatively more. So, it has to be, I believe, 0.72 and 0.54, right? These are the only options which are satisfying our condition. Okay, these are the only options which are satisfying our condition. The correct order of electron gain enthalpy. See, as I told you, you have got group 17, fluorine, chlorine, bromine, iodine, astatine, right? Group 16, oxygen, sulfur, SETE. Perfect. On moving down the group generally, electron gain enthalpy decreases, right? Electron gain enthalpy decreases, but chlorine has got more electron gain enthalpy than that of fluorine because of the smaller size of fluorine. Similarly, sulfur has got more electron gain enthalpy than oxygen because of the smaller size of oxygen. Perfect. The order here becomes, the final order here becomes, as I told you, Cl, then Br, then F, then I. This is the actual order of electron gain enthalpies. Here what the order becomes? Oxygen comes at the end. Oxygen goes to the end. So here the order is sulfur, Se, Te, and oxygen at the end. These are the actual orders of electron gain enthalpies, right? In case of group 17, fluorine does not go to the end. Fluorine takes the third spot. But here oxygen goes to the end. I hope I'm clear what I said. The correct order of radius. These are isoelectronic species, right? And they are given with correct set of radius, more, less, less. Guys, all these sorts of questions we have done. What about this one? What about this one? What about this one? What about this one? The element Z is equal to this, discovered recently. Okay? It is the F block element, first of all. Is that? Do you remember I gave you one trick in the last session? Check the last two numbers. 1, 4. So 14th group. 14th group means carbon family. 14th group is carbon family. 14th group is carbon family. Yesterday we have seen this. An atom has electron configuration of this. Where will you place it? 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 Do you remember the yesterday's trick? Do you remember the yesterday's trick? N minus 1d plus ns electrons. 3 plus 2 is 5. 3 plus 2 is 5. Yes, 3 plus 2 is 5. The element with atomic number 118, last, that is a noble gas, right? It comes in group 18. It comes in group 18. So 119 will again come in group 1. 120 will come in group 2. This question we already solved many a times, isoelectronic species 1. We see if there are some new questions. Okay, what do you think about this one? These are second period elements which are given to us. We have to arrange them on the basis of ionization energy. Ionization energy. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Right? This is the expected order. This is the expected order. Ionization energy moving from left to right increases. But here you have to interchange the positions. Boron, no, it's, wait. Boron you have to keep here, beryllium you have to keep here. Similarly, nitrogen you have to keep here, oxygen you have to keep here. What is the logic? Logic you already know because of the half-filled configurations. So actual order will be what? Actual order will be lithium, boron, beryllium, carbon, oxygen, nitrogen, fluorine, neon. This will be the actual order. This will be the actual order. Okay? This will be the actual order. Correct order of first ionization potential of these. What do you think? Done? Which one? Nitrogen, of course, will have maximum, right? Half-filled configuration. That's the only option which says nitrogen has more. Electron gain enthalpy order of group 16. I told you, oxygen goes at the last. Oxygen goes at the last. Oxygen goes at the last. Guys, just give me a second. Okay, this is done. This is done. Look at this particular question. In which of the following options the order of arrangement does not agree with the variation of property indicated against it? Quick. Is this electron gain enthalpy order? Is this ionization energy order? Does not agree. Does not. So what is the answer of this question? You know, nitrogen has got more ionization energy, first ionization energy, than that of oxygen. So this is wrong. This is wrongly matched. Rest everything is correct. These are some oxides you have to check. This is a metal oxide, group first, right? Metal oxides, what do they do? They form basic oxides. This is basic. Perfect. So 1, you are connecting with B. So it's option A or option 2. Now Cl2O7, non-metallic oxide. It forms the acidic oxide. 4 with C, 4 with C, 4 with C, right? Now 2 and 3. Now 2 and 3. What do you think? What do you think? I told you already, your metals form basic oxides, non-metals form acidic oxides, metalloids form the amphoteric oxides. So it's absolutely, all of you are perfectly right. It's option A, which is the correct answer of this question, right? Perfect. These are again the similar questions which we have already solved. Okay, answer of this particular question I would want in the comment section of this particular video. So guys, with this practice session, your class 11th in organic chemistry is done and dusted. If you have watched the yesterday's session and today's session, you're not supposed to solve anything extra. You're not supposed to read anything new. Okay? Perfect. Right? The next session which I'll be taking, that will be class 11th physical chemistry marathon. And I'll let you know the schedule about that as well. Okay? Chalo guys. Chalo, I'll see you. Bye-bye. Take care. God bless you all.